Okay, let's get started. First of all, are there any questions about homework 3? How many people have gotten started on, are there people who've gotten started with homework 3, the movie thing? Has there been anything people have seen or learned, or any questions about homework 3?
One thing I saw is that there are a lot of movies that have 0 listed as the budget, so that it's kind of like they're missing.
Okay, so you're saying movies have 0 as their budget. Okay, there are a lot of movies I know that look like they have 0 as a budget, but that's just as someone I've noticed from watching them. In fact, I guess you're telling me that if they have 0 as a budget, is that a likely candidate for missing? I would say that's likely missing data. How would you get it? That's maybe an interesting question. Okay, so then how would you first of all, figure out, does anybody have an idea how they would confirm whether or not the get confidence that 0 meant missing data? Okay. Someone's saying use multiple data sets, so use something from the outside. That might be good. Okay. I would also guess that probably the ones that don't list their budget are probably smaller movies that probably didn't do very well, that or that kind of weren't meant for big releases. You guys saw that I had at the beginning of the semester, you had to sit through a few episodes of my TV series. That didn't have a 0 budget. I actually managed to burn I almost got into 3 figures. Okay. But no one would know, let's say, the budget for something like that because they weren't investors. It wasn't public news. So people are saying multiple data sets. I would be curious to check to see if the ones with 0 are in fact small films that just never report this. Okay.
Actually, I found that a good number of the films that had 0 budget were also less than 60 minutes in length.
Okay.
Which I also found weird for movies in general.
Well, the question of what's a movie, again, I don't know where that data came from. One thing that's true is they could be short films, and short films are probably like that. Exactly what qualifies as a movie is, depends on the guy who made the thing. I am used to thinking of a movie as a thing that you see in a theater. That may or may not be wrong. These may be foreign films. These may be something. So I think that's interesting, but it might be curious to try to figure out why that is. Okay. And, again, if they're short films, if the budget is not given and the length is, are all short, then that's probably interesting. Okay. Any other observations or comments about the homework 3? Okay, some budgets use other currencies. That's probably true if they are overseas. And again, a lot of some of the movies may very well be international films. And obviously, that's one thing that you'd have to normalize if you were going to treat these things intelligently. Any other observations or questions about the movies? Experiences with the movies? Okay. Anything else? Okay, anything about the projects? Again, at this point, you guys should be starting to think a little bit about projects. Any questions or comments about the projects? I guess one change is that there was a project there about doing video analysis to try to identify features from Zoom calls and people's headshots and stuff like that. And Yunting is now the a captain of that project. So if you're interested in that, she's actually a good resource to talk to about that. Any questions about the project? Okay, so what I'd like to talk about now is data visualization. Again, at the end of last class, I showed you the kind of plots that you guys produced on the previous homework, and some of them were sort of insightful and told stories, and some of them didn't. I think that learning to visualize your data effectively is important for many, many reasons. One is you're often going to be faced in life with trying to present your results to other people, and the difference between effective and ineffective visualization is quite dramatic. There's also reasons why you want to look at your data for you to understand it, and this is kind of important, okay? To identify where the outliers are, to identify when you had an artifact, okay, some mistake in data collection. This is the kind of thing that usually comes up when you plot the data in the right way, okay, to see patterns in data. Okay, many people like, obviously you guys are, many of you are going to be interested in studying machine learning. The one thing I can tell you is that if you take data that you haven't really visualized in any way, okay, and try to immediately feed it in an just feed it to a model saying everything's going to be fine, usually, often weird things happen and you get into trouble. And I think visualization is very important. That's why I want to spend a fair amount of time on it. And again, why do we do it? Well, one reason is exploratory data analysis. What does your data set really look like? Another one is what I will say, error detection. Did you do something stupid along the way? And presenting it to others. I guess I just really said that. And the reason this is something I like to beat on is that, like I say, I am used to students giving me plots that are really terrible. And visualization is one of these things that everybody should be able to get right. Okay, any questions? So the classic demonstration of why visualization is important is a set of data sets called Ascombe's Quartet. Here you have 4 data sets, okay? All of them have the same mean, X values, mean Y, same mean Y values, the same variance in every dimension, the same correlation between X and Y. Can anyone tell me what's going on in any one of these data sets? You can look at the numbers and you can tell me what's going on. Can anyone tell me what's going on with any of them?
Well, the fourth one has all the X values stacked up at 8, except for one of them.
Okay, so the fourth one
And-
looks suspicious in that you
Yeah.
can look at it and you're seeing that you see a lot of 8s and one of those there. So something there, you can see that with your eyes. Can anybody see anything else with their eyes? Okay, now suppose we plot them. Can anybody see anything with their eyes? Okay, what is the story that each one of these data sets is trying to tell? Okay, I think that this last one, you figured out the story from looking at the points. Okay, that this is basically a horizontal line with an outlier. Okay, what is the story of this data set? This story, it seems clear, are points with a linear relation that are sampled, that there is some variance, but there's a linear relationship between these. This, if we look at it, is clearly a linear relation with an outlier, a different kind of outlier, right? And that, otherwise it's got a great fit, and you can tell that the regression line is wrong because it's chasing the outlier. This one is clearly some kind of a nonlinear function, possibly a parabola, probably something quadratic, okay? Is it clear? It should be clear to everyone that when you see the points, it's easy to tell what the story is, okay? And without the visualization, you can't tell what the story is. Any questions about that? Okay, good. And when it comes to visualization, I think that, you know, one needs to develop some kind of an aesthetic to what is a good visualization and what is a bad visualization. And there's some questions of appreciating graphics that are a little bit like appreciating art. These are two paintings that are in the Metropolitan Museum of Art in Manhattan, which I dearly hope you guys will visit sometime if you haven't already. Does anybody know who did the painting on the right?
Jackson Pollock.
Jackson Pollock. Good. Very good. Anyone know who did the painting on the left? Okay, that was Jean-Louis David. Okay, from, a French painter. That's The Death of Socrates. Okay, which painting do people like better? Okay. And this is one that there's, again, I'm curious to see what people's answer is. There's no law that, I'm just curious to see. How many people like I think there's a way I can, what do you call it? How do I see whether people are saying yes or no to things? This is something that seems to come and go every once in a while. But how many people like the painting on the left, The Death of Socrates? Okay, I'm seeing one person who liked The Death of Socrates. How many people like the Jackson Pollock on the right? Okay, I'm not seeing anyone confess to liking it. Okay, I happen to like both of them. Okay, but when you talk to art critics about it, obviously, in order to like one or the other, you've got to have a reason. When people are talking about the Jackson Pollock, people like and when you you like the energy. There's a certain energy and rhythm and excitement when you're standing in front of that painting. Okay, and that's kind of the language people will talk about. When people will look at the painting on the left, they will say, my God, look at the realism. Look at the pathos and the emotion and stuff like this. There is a language for talking about art that is what people use to help decide what is good art and what is bad art. And likewise, to understand the lesson from this that I'm hoping people will take is that you need to learn a language for talking about data visualization. And my favorite language from data visualization is from a guy named Edward Tufte. And I'm sorry, I should have done this beforehand. So let me just get this. There you go. So Edward Tufte was a professor at Yale who wrote a bunch of books on data visualization. And these are some of the most beautiful books I have ever read. And the absolute best one, if you must know, is this one called The Visual Display of Quantitative Information. This is the single best book to have at home for you reading when you're on the bathroom. Okay, because all it consists of, basically, are classic examples of visualizations from data people produced. And he has kind of a theory or a vocabulary to talk about what makes a good mathematical graphic, what makes a bad mathematical graphic. And what I'd like to do is try to, teach this particular aesthetic, some of his ideas, as kind of a way to talk and think about these things. So when we talk about it, what I'm going to be interested in is, some of his principles are that you want graphics that maximize what he will call the data ink ratio, that minimize the lie factor, that minimize chart junk, and of course, use proper scales and are clearly labeled. So let's try to understand this and learn that maybe we can develop a taste for what makes a good graphic or a bad graphic. So here we have two bar charts, okay? You've got a bar chart on the left, okay, which has, three-dimensional blocks, which has shadows, okay? You have a bar chart on the right that's just sort of bars. Which one of these do people like better? This is one where there is a, it would be better if I saw cameras and faces and discussion. Which of these do you like better? It's the exact same data.
I mean, the perspective of the first one makes it kind of hard to tell heights or relative heights.
Okay, so the first one, okay, we're gonna say is actually gonna fail two of Tufte's standards. One is that there's this kind of what you're saying is sort of a little bit of a lie in that the perspective drawing, okay, is what you call it. The fact that there's perspective maybe makes it harder to tell if this one is, for example, bigger than this one, okay? You know, kind of as things recede in the background, they get smaller. It's harder to see whether that. So part of it is that with the perspective, you get a lie, okay? But the other part of it is that there's a lot of the ink that is spread here is kind of just for effect. Does everybody think the shadow is cool? I think the shadow is kind of cool if I'm looking at it as a picture. But the shadow is ink that is not really being used to present the data, okay? The fact that you've got three-dimensional things is an example of ink that is not being used to present the data. So one of Tufte's criteria is he thinks that generally speaking, a good graphic will have more data ink and less, you know, a higher ratio of real data ink on the thing. And certainly I think that by the data ink test, what you see on the right passes it much better than the one that's on the left. Any questions about that? Okay, fair enough. That's one I think is kind of obvious. The other thing that he talks a lot about is what you would call he calls the lie factor, again, which is kind of a ratio of the effect size of what you see in the graphic divided by the size of what you see in the data. So these are some newspaper graphs that he showed, okay? What do you think when you look at this doctor thing? This is showing how there used to be, it looked like a giant army of doctors back in 1964. But slowly people are going down into the, to 1990. The ratio of doctors, there's less than half as many doctors. You know, something is a little bit less than half as many doctors. But what is the size difference between the doctor on the left and the doctor on the right? Is it accurately reflecting the difference in the value between these two numbers? Okay, can anybody, who here thinks that it actually is reflecting it? Or do people kind of agree that the dramatic impression of this point here is more than twice as big as the one on the right?
I think it is, but only by height, not by volume or like area.
Okay, so what you're saying is that it's properly representing what's probably doing is the guy is saying, yes, I drew the heights to be in proportion. So what you're saying is that the height of this doctor is presumably a little less than half the height of this doctor. And that I might believe. But are doctors one-dimensional quantities? Doctors live in 2 dimensions. They don't live in 3 dimensions here. They live in 2 dimensions. But does everybody see that when if you you double the height of a box, the area of the box went up by a factor of 4, okay? And so you end up getting this nonlinear perceptual effect. And that is an example of a lie, okay?
It's great if you want to mislead your audience, though.
It's great if you want to mislead the audience. Another book I have, which again, since I don't get to do this very often when I'm usually teaching, because usually when I'm teaching, I'm not in my office, but I think I've got another book here, if I'm looking. No, shut down. There's a very good book called How to Lie with Statistics. Okay, and that was another example of this thing. And again, you see the same phenomena on the right with the barrels. Okay, except here perhaps there is a 3-dimensional thing going on. Okay, But even here, I don't know what it's doing, actually. It looks like this barrel is quite a bit shorter, even though there's a very, the prices are relatively close to each other. Okay, so God knows what he's doing there. Okay, any question? I think you get the idea that you should be trying to make the effects what you see. Okay, here is a example of another type of lie on a statistic. When President Obama was trying to was letting a certain set of tax cuts expire. What is the effect that you see on this graphic about tax rates when the tax cuts expire? What is the effect that you're seeing on the television?
Visually more than a quadrupling.
Looks like it's going out of control. Does everybody see that? This is really going to level everyone because the tax rates are going up by a factor of 4 or something like that. Now, are they really going up by a factor of 4? How much are they going up by?
Like a 10% increase about.
Something like that. Where do you see it? Where do you see? How do you know? The truth is that they made it misleading because they didn't show the whole range of the scale. Okay? On the right is a properly drawn bar graph. Okay? And the first one, the one on the TV shows a calamity. The one on the right shows a modest increase. Okay? So there's this notion, again, I think you think of it as graphic integrity, lie factor, okay? In this case, the figure on the television figure is a lying figure, okay? Any questions about that? The argument here is that if you're going to represent, a bar graph, usually you want to show the whole thing, okay? Certainly, you have to make it a point of properly labeling your axes. Usually, you should start at the origin to make sure people are seeing things, or else doing something to make it clear that you're not showing it, like maybe showing a cut in the bar or something like that. Any questions about that? Okay, I think people agree with that. Now, this is showing monthly sales for a company. Which one of these, in which one of these is the company's sales dropping fastest? Which one of these shows a company that's in trouble?
One on the right, the top right.
One on the right, these guys, my God, okay, something must have happened. Maybe it's the pandemic, okay? Which one is showing a company that's basically, doing things pretty normal? It looks like not much is happening. Okay, I'm going to argue that obviously this one, it looks like nothing really interesting is going. There's been a decline, but it's not that big a deal. The truth is, of course, is that all three of these figures are showing exactly the same data. Okay, the story your eyes are seeing is different. And part of that is a question of what that's basically, in this case, what is the aspect ratio of the graph? Okay, will cause some kind of a different perception. Okay, so which one of these would be kind of the one that would reflect truth the best? Okay, or be easiest to understand? They're all saying the same data, so by that measure, you might say it's reflecting truth. My sense is that people tend to are used to seeing graphics which have kind of a something like the golden ratio. This is sort of the dimensions that you're used to seeing a graph in, okay? And so presumably, unless there is a really good reason, okay, you probably want to keep the aspect ratio of what you're seeing to what a convention is, okay? Any questions? There are certain sort of psychological things that say people kind of understand 45-degree lines, angle lines, better than they understand flat things or steep things. But that's kind of fuzzy. I think that just because people are used to looking at charts which have something like the golden ratio, which means that one side is about 1.6 times the other side. Okay, that's probably the easiest way to see these things. Any questions? Okay, good. Now, what about this graphic? Again, one of the things that's fun about Tufte's books is it's filled with this graphic here. What do we see is, what do we think of the graphic on the left? Anybody think anything about the graphic on the left? It's showing the fuel economy standards for as a function of year. What is the effect that you're seeing when you look at that picture? Somebody.
Perspective doesn't make it very honest.
It doesn't make it very honest. Why isn't it very honest?
Because
Well,
normally you'd expect things farther away to be smaller. And in this case, they're doing that in the graph, but makes the line for 18 miles per gallon really small compared to 27.
Right, right. Again, you would expect that. Again, the length of the line is supposed to be proportional to the value on it. This is what happens when you plot the data correctly. This shows that with time, fuel standards have been increasing, but not going crazy. This is very distorting. The other element, another element of what you call it, that Tufte likes to talk about, is this idea of reducing what he would call chart junk. A chart junk is a visual element that is kind of unnecessary. Okay. It's not only non-data ink, it's distracting. It's things like extra uninformative color. It's things like extra decoration or grids. Okay. It's things about dimensionality that you don't need. Okay. I think in a good graphic, okay, you want the data to tell a story. And it's not just about decoration, it's about a story. So let's look at these two things, first of all. First of all, have any of you ever seen this? Okay. This is a building that's on Long Island. Actually, I happened to have seen it a week ago or so. This is out in a town called Flanders, out near the East End. Okay. And what it is it's a building that used to sell duck eggs. Okay. They used to have a store for selling duck eggs. This is called the Big Duck in Long Island. If you Google Big Duck, you will see the story of this. And, this building has become famous, not only because it's kind of cool to look at, but it's kind of, the notion of a graphical duck, okay, is a world where you have things that are on the, figure that kind of, don't really contribute to the function of it. We agree that what makes the duck interesting is also what in this case, what doesn't add to the function of its ability to sell as a store to sell duck eggs. So again, we have to be aware when we see such things. Now this on the left is a figure that is showing, maybe it's not completely clear. It is showing over 5 years, okay, what were the percentage of college students that were 25 and over, okay, and the ones that were under 25, okay? So the top figure is showing the ones that are less than 25. The one on the bottom is greater than or equal to 25. What do we think about the graphic on the left? Do people understand what it's showing us? It's showing us for 5 years, 1, 2, 3, 4, 5. What's the percentage of college students that were 25 and younger? And what were the percentage of college students that were, these were the ones that were 25 and young, these were less than 25? These were greater than 25. What story is this trying to tell, first of all? There is a story that this is trying to tell. Can anybody take a look at this and tell me what story this is trying to tell?
The average enrollment age went up over those 5 years.
That's right. Okay, so it's saying, my God, those old people are going to college. Okay, that's what that's saying. Now, what here is kind of, if we had to simplify this graphic, how could we simplify this graphic without losing information?
Get rid of the 3D effect.
Yeah.
Get rid of the 3D effect. Okay, so you want to get rid of the green and the blue. Okay, that's one way to simplify it.
Could we just make it a double bar plot
Double bar plot means what?
or a double line plot? Just simplify the y-axis. Like it's kind of blurry in the image, but I can't really tell where the break is and why this upside down area even exists.
Okay, so there are a couple things that are going on in what you're saying. So one, as you notice, there is a break in this thing, so you don't really know how far ahead those numbers are from this number. Again, it's a little blurry, but if you could have read it, maybe you would see. But because there's that break, you don't get any visual effect. Okay? You're saying that I should draw this as what? As bars? You wanted to have a 5-bar plot type of thing?
Well, yeah, aren't you trying to compare the red and the yellow? It would be easier if they were side by side instead of this weird
Okay, so what you want to
inversion
say
thing going
is
on.
maybe it would be better if you had compared 5 in yellow. So you want to say these are less than 25, greater than 25, or something like that.
Or
That
yeah, or
might be
even
that might be better. Can anybody think of any other way to simplify this?
Flip the yellow one and put it on top of the red one.
Flip it and put it on top. Okay. Why do you do that? Okay, let's think about that. What do you mean by flip it and put it on top?
Like, it's upside down. Make it right side up so you can see both of them on top of each other.
You're saying that you want them to be flipped upside down. Okay.
No, the top one is, I want to make it right side up.
You want to make it right side up. So you're saying that if we flip this thing over, it would be more revealing. You think that it would be that this other one should also go like this. Is that what you're trying to say?
Yeah.
Okay, is that true? Think about it hard.
no.
I don't really know. I can't really read the scale because it's kind of blurry.
No, but let's think what it means. These are the percentage of kids that were under 25. This is the percentage of kids that were, these were the percentage of people who were over 25. These were the percentage of people that were under 25. Do we think both of these charts should look like this? Why not? I'm seeing some head shaking. Why not?
It's okay how it is, but why are they filled in? Like, couldn't we just have 2 lines? Because why is the top one filled in on the top area? It's just so unintuitive.
Okay, it's unintuitive in many ways. So first of all, one thing to note is, what is the sum of the percentage of people who are over 25 plus the percentage of people that are under 25? What should that add up to?
100.
Should be 100.
So these things should kind of fit in a nested piece, right? Perhaps the right figure, if you wanted it, was something like this, where these were the old and these were the young, right? Does everybody see all of these 5 data points are completely derivable from these 5 data points? It's simply 100 minus X. Okay. So I would say that either you represent it as out of 100 and you make it 1 block, okay, or you delete this entire thing on top, okay, because there's no other information there. So everybody kind of see that that doesn't give you any information at all, okay. Any other thing wrong with this graphic? Tufty says this is the worst graphic that ever appeared in print, okay? Can anybody see anything else about this graphic? Once we have gotten rid of the top and once we have gotten rid of the blue, that still looks fishy.
The red coloring is also meaningless.
Well, red
How far you
coloring,
want to
okay. Anything in particular that people see? One thing that I don't like about this, that if you stop and think about it is a little bit crazy, is why is this a curve? See how there are these curves and bumps between these things? What is the curve connecting these things supposed to mean? It means absolutely nothing, right? There's no data there. These curves are just weird ways to interpolate between them, okay? The right way to present this thing is probably either as just something like this, or maybe even just 5 points, okay? And that would have conveyed all the information and it would have been simpler. Any questions? Okay, I think that point is now clear. So let's practice simplifying graphics. I do think that people naturally, if we're listening to to Tufty, we should be trying to reduce chart junk. We should be trying to minimize data, maximize data ink, the data ink ratio. Can anybody think of anything to do with this plot? Or this is a plot, it looks like of, sales or profit, percentage of profit as a function of time. Anything that we should do to improve this plot?
We don't
Remove
need
the vertical lines.
Okay. Remove the vertical lines. Now, vertical means up, down. Okay. Presumably you don't mean the bars. You mean these things, the ticks, right?
Yes.
What if we got rid of those ticks? Okay. Does this look better? This thing I here referred to, those kind of heavy grids, Tufty would call a data prison. Everybody see how you have your data behind bars? Okay. If you have it like this, I think it looks certainly easier. What's the ostensible reason for the data prison, however? Can anybody think of a reason why you have the data prison? What are those grid lines supposed to help you with?
If they were points and not bars, it would help you determine where the points were if they were far away from the
Helps
axes.
you to determine it. So one thing that's clear is without, for example, the horizontal lines, it's probably hard to tell if this number is above or below 15%. That's kind of what the horizontal lines are probably trying to tell you, right? But, okay, so now we got rid of that. Do people like this plot better? Okay, again, the ones with cameras sort of do. Okay, but that's not a very representative sample. Is there any other way you can simplify this plot to reduce data, to increase the data ink ratio or reduce chart junk?
We can remove the background color.
Okay, the background color was blue. Why do we have a background color? Now there is less ink. Okay, is this better?
Yes.
I kind of like it better, but maybe but it's clear that by Tufty's thing, this is better. Is there any way to simplify this plot further?
Do we need the other two axes? Like we could only keep the Y and X axis?
You're telling me you don't like that kind of thing, right?
Yeah, it's unnecessary.
That away. Does this look good? Is this better? Certainly the data ink ratio has increased. Is there anything else that we should remove to make this a better plot?
I like to put points instead of a bar.
So one idea might be that you put, instead of plotting points, this I think is an interesting philosophical question. If you just plotted points, would that be better than bars? If we are with Tufty and we believe in reducing the data ink ratio, points would probably be better, okay? There's maybe some room for taste here, okay? But that would be one direction that you could go in, okay? And I don't completely know why the bars are necessarily better, okay? But here was one other example of deletion that was better, okay? What if instead to kind of get back those horizontal lines that were useful, we remove ink instead of edit? Does everybody kind of see this? This to me is kind of a pretty elegant solution to this, okay? This is, I think, is an elegant design that lets you read these things without a lot of the chart junk. Any questions? So learning to think in terms of these kind of concepts gives you a, what you call it, a way to think about these plots. And again, you guys use Python, you guys use matplotlib, or maybe even other libraries. There are ways of plotting things that do all of the kinds of things that I talked about here, okay? So a lot of it, it's not like, oh my God, he's got to write some special code or something like that. It's questions of what do you think is interesting to show? And, you know, you have control of that in Python. Any questions? Okay. Any other questions or comments about this? So when you think about mathematical graphics, there are a lot of different kinds of plots you're allowed to make. And this flow chart here, I kind of like because it gives you an idea of what, you know, you should kind of know why you're actually using a particular style of graphic. Okay. So if you want to show a relationship between two variables, that's a good one. A scatter plot is a good way to show that. You have ways to do scatter plots in higher dimensions. Often you want to compare different values, not so much show the relationship, but here you might think about bar charts, you might think of column charts, you might think of line charts, you might think of just points. Okay. There's questions of whether or not you're showing one line on a plot or another plot. Sometimes you want to show a distribution, okay? Maybe you're going to use column histogram or line histogram, okay? Maybe you want to show how you partition a thing into a variable into different, you know, different categories. Maybe this is where you use a pie chart, okay, or a stacked area chart or something like that, okay? So it's interesting. It's good to know about a bunch of charts, why you're using them, and what the interesting properties are. Any questions? Now, the simplest plot, okay, when it comes to showing data, is actually just a table, okay? And tables are actually often very good ways to present data. What are advantages of tables? Well, one, you can really show the numbers, and so it gives some kind of an impression of precision, okay? It is a way to visualize many dimensions, actually, many variables in a way that people can understand it. You can't understand a picture in 8 dimensions, but you can understand a table with 8 columns, which is really representing data in 8 dimensions. You can represent heterogeneous data. Some things can be numbers, some things can be labels, okay? And if you're building a table, when you have small numbers of points, it can actually be a very efficient way to represent things. You don't need a lot of space or ink to understand it. But there is a difference between good tables and bad tables. And this is something that I want people to try to think a little bit about. Here I've got a table. This is a 6-dimensional data set showing properties of different countries. Every row is a country. Every column is a property of a country. Okay? And this is a perfectly fine table, I guess. Okay? Except is there a way we could make it a better table? Any ideas as to how you would take this table and make it a better table?
Depending on what you want to focus on, you can sort it.
Okay, so you say sort it. Now, here you mean sort the rows?
Yeah, like say if the main focus was to show GDP, just sort it on the GDP.
So
Just
one
to put
question
linear
is,
like.
what is it that you're trying to show on this table? If you're trying to get focus attention on GDP, sorting it by GDP would be right. What other ways would there be to sort it? Is there any other permutation of rows that might be interesting? Okay. Why might we want to sort it? Is there any reason we might want to sort the countries by name?
Easier lookup if you're care about a
Easier to
particular
look
country.
up. It's easier to see if a country is there, right? So if you're making a case about what which countries win in GDP, sorting them by GDP would be good. You have the freedom. It's clear you have the freedom to order by rows, and that wasn't really done. Is there any other way to improve a table like this?
We can make all the numbers right justified so that it's easier to read them.
Okay, so one problem is it's very hard to tell which of the big numbers are not because they are left justified, right? If we right justify these numbers, suddenly, for example, the population of China is going to jump out at you, I think, in a much bigger way, right? You'll be able to tell which numbers are bigger. So that I think is true. Is there anything else that we could do to this table?
The
We need
GDP.
units. Oops, sorry.
What?
We need units.
You need units. Okay, maybe you need units. You could perhaps describe a unit, okay, up here, maybe square miles, density, per million. So maybe you would want more information up there describing the units. That might be helpful, okay? Any other things you could do to this table?
Make GDP an integer instead of a float.
So one question, if you notice, GDP is an integer. Is if we got rid of all those zeros, this would obviously do nothing to hurt the table, right? It would make it easier. The zeros are contributing nothing. Anything else we could do?
For population, maybe we can use median, so we can reduce some digits.
Okay, so one possibility is we may not care about that last one person in Japan. Okay, it might be that if you had this in million, okay, that might be easier. Okay, there's some debates as to whether or not you want people would understand it better in million. It's true that when I look at a number like this, I can't immediately tell. I have to add mentally I have to add commas in order to understand these things. Okay, so maybe that's actually useful in this. Either I think converting it to millions or maybe adding commas. Anything else you could do to improve this chart?
Move GDP all the way to the left because that's what we're talking about, and sort it by GDP.
One possibility is that if you're going to sort it by GDP, maybe you'd want to make that obvious by putting GDP first. So we have the freedom to arrange the columns the way that we want, right? What should be the principle of arranging the columns? Is there any principle that we could use to decide what order the columns should be in?
I think country on the left makes sense because that's the label for each row. And then
Okay.
Immediately to the right of that should be whichever column we're making a point about.
Maybe the column you want to make the point about, but what about, so is it only that the column that we care most about should be next? Is there any other principles that might be used to try to decide what the columns should be near each other?
You could sort them by highest variance to the left.
You want to put the ones with high variance to the left. Okay. Maybe. I'm not sure I see why. Okay. The argument that your eye is, the stuff that seems like it's changing the most, you want to focus attention on to the left, maybe. But that would not be my goal. What other criteria should be used to order the columns?
Density is calculated from area and population, so maybe it should be together, like population
So
area.
I think that you want to use it for making comparisons. What of these things do you want to compare? Okay. And I think you said right now, you like the idea of comparing it. You think you'd like to move the population maybe over here. So maybe it would be something like area and population and then density. Okay. Or maybe even population area density. I don't know. That might give you a way to make some kind of comparisons.
Yeah.
Any other columns that should be near each other?
Birth rate, mortality.
Yeah.
I would say these two, if you put them next to each other, they invite comparisons, right? The reason you want to put a table in there is so you want to look at it. And in a good data table, you want to look for what are the comparisons I want to know about. You know, is it the case that, for example, the countries with the higher birth rate have the higher mortality? Okay. And again, I don't know what the unit of birth rate is, but actually, God knows what's happening in Afghanistan. That's really something, right? They're not getting born, but they seem to be dying. Okay. In most other countries, the places with the highest birth rate have relative. Again, I don't know if the birth rate is a high or low. We have to know what the unit is. But I'd want them for comparison purposes. Anything else you could do to the plot? The table. I think most of these things we did. We could order rows, we can order columns. We can, what you call it? You know, write justify. We can use font, some emphasis like color or bold in order to highlight stuff we want. And finally, there's things about column length descriptors. One thing to note here is there a way, if I look at this, I see that all this white here is one thing I'm seeing. How could I reduce that white? If I had made this thing birth rate, okay, on two lines, suddenly they would, the spacing would be more proportional, okay? So what was my favorite plot here? This was my version of the plot. I ordered it by country. I did group population area density. I grouped these things. Okay, actually, I probably should have put birth rate and mortality together. I think you guys convinced me that's probably better. But I bolded things and I added the commas so I could read the numbers more easily. And now it's clear to me, certain things jump out. My God, they have a lot of people in China. My God, Russia is a big country. My God, they pack them in like sardines in Japan. Okay. My God, I don't want to be in Afghanistan. Okay. Which is the richest country? It looked there, the US was the richest. Okay. Any question? I think the point is clear that when you're building a table, you have degrees of freedom and you should use it. Okay. A table is not just to say you have a table, but that there's things there you're trying to show. Any questions about that? What other things about common plots do you know about? Well, you guys are quite familiar with what I would call, they call line charts, where you have an X and a Y variable. Which of these look most interesting to you? Okay, if we take a look at these plots, what do we, first of all, there's many different ways you can draw line plots. Okay, are there any comments or discussions about things? Okay.
The top left one has kind of smoothed it.
The top left one is some kind of a very, very smooth curve. Okay. And so first of all, what's interesting is that this is just showing kind of a, it looks like a sinusoid. if it's drawn from data, you don't see any data. The smoothing is so high that you don't actually see the data. Okay? One of the things that I guess is good about a line plot is that it shows the, a line segment plot is it shows the data. On the other hand, what do we learn from these line segments? Everybody's drawn plots like this. What do we learn by drawing the line segments between the points? Is there something that it really shows?
The dips and highs.
What?
The dips and the highs are like explicitly called out because of the points and the lines.
Okay, so you're saying that maxima and minima get called out that way. And maybe that brings the attention to it. Okay? I'm not sure whether you would, and maybe you say you think you see that better than if you didn't have it. That may be true. I'm not going to argue with you.
Transitions are clearly brought out because of the, like if you see from September to in between of October, there has been a huge dip.
Okay, so you're saying that you think that that in fact the lines kind of, the slopes show you big changes.
Yes.
Maybe that's true. Okay, although I'm a little bit less sure of that. But actually I'm not sure I'm wrong. Okay, that might be an effect of it.
Mm-hmm.
Typically, the way I would, one way that again, one does that fairly often. Here you have a plot where you don't show the data at all. You're just showing the line and the dots don't appear. Why might this be a good choice compared to this?
If we just want to show the trend and not
show the trend, that might be it. Part of it may be if you have a large number of points.
Yeah.
This thing has a lot more points than that one does. And that it could be the case that the points step on each other.
Yeah.
What about this one? Do people like this one? This is one where you show the data and you show a fit. This I kind of like, actually, in general. Instead of showing the connected lines, you show me the actual data points and you show me the trend.
Yeah.
The trend lets me see what's going on, okay? But the actual data points show me whether you're lying or not when you produce the trend. So generally speaking, I like these kind of things, okay? I typically, I kind of like, when my students show me a graph and they say, look, everything's getting better, I want to know where the point is that produced that, okay? And, so I think this is a good option for a lot of things. Any questions? When you've got two or more variables, okay, a scatter plot is a good thing, okay? And this enables you to show every pair is going to be a point, and it's a good way to visualize 2 dimensions and possibly with higher dimensions, okay? In my lab, I know we often have high dimensional data sets, okay? And what the students will usually do to present it, that is often usual, is each row will get 1 point, but we will somehow project all of our higher dimensional data down to 2-dimensional through things like maybe principal component analysis, which we'll talk about later, or things, some other techniques, okay? Or we can use bubble plots to show more dimensions. Okay, here are 2 scatter plots of the same data set. Which one do people like better? The one on the left or the one on the right?
right.
The one on the right
Why do you like the one on the right?
shows the density better.
Shows the density better and stuff like that. What is the difference between the thing on the left and on the right?
The left one has darkened most of the area, and on the right one, it's like you have different
You see the points. Here the points are all overlapping each other. Does everybody kind of see that? It's amazing how often people will show me a scatter plot that is a big blob. The key to making your scatter blob, if you've got a big blob, this key is simply making the dots smaller. Does everybody kind of see that? So think about the size of your dots and whether you've got something that's just a black hole, or whether or not you have something there that would benefit from shrinking the dots. Any questions about that? With the dots, you can, with smaller dots, you see density. With the bigger dots, you just see a cloud because everything's obscuring each other. Any questions? Is there any way to draw this better? Any other ideas how I could improve this plot?
If you had a small alpha to the points, you could probably even see more of the center or more of the density.
If I had a what?
A small alpha, like a slight transparency to every dot.
Okay, so there's another question of there's when you're plotting these things, there are, I think the simplest thing to do is to reduce the size of the dot. Another thing that you can do is increase the transparency of the dot so that you start to see overlaps. Okay, you would like that. It's often the case that that dots overlap each other. That's kind of what the problem is. One way to take care of that could be by changing the the transparency of each dot. Okay, if you have dots on the left, okay, these, if they overlap, two of them, you can see where the overlap is. The ones on the right, you overlap it, you don't see that there's the place where they're overlapping. But an even better idea often is something called a heat map. And in a heat map, basically they color each point based on what its frequency is. So the thing on the right, this is a distribution of how many, at a data set of men and women based on, of people based on BMI. And we see that there's a small number of incredibly heavy, okay, very heavy people, okay, and those are the ones out here. But there are a lot of people with, weights, conventional weights. By using color to kind of show what the density is, okay, that's what you do on a heat map. You get a much better sense of where the population really is. Any questions about that? This should be obvious from here. Okay. Again, you could have done this, by the way, with, like I said, with the transparency idea. Okay, it would all be one color, but again, it would still the depth of the color would make a difference. Okay, and you would be able to see densities. Any questions? Now, if you want to show more than 2 dimensions on a plot at the same time, you can use a bubble chart. Now every dot is more than a dot in order to convey more information. So what does this plot show? Let's look at this plot. This is a very, very nice plot by a really wonderful website called Gapminder, which is trying to understand how the world is distributed. What is this plot showing? Can anybody read the plot and tell me what it's showing?
You have countries plotted on the x-axis by their GDP per capita, on the y-axis by their life expectancy.
Okay, so what do you learn from this?
There's a positive relationship between, income and life expectancy.
Richer countries look like they live longer. That's one thing that it's learned. Okay. What else do you learn when you look at this thing? Okay. I mean, are there other dimensions? If you take a look at this thing, what do you kind of see? I love looking at data plots because they tell me stories.
The size of the points seem to indicate population, and it seems
The
like there's
size
a
of the
sort of
points indicate population. So now that's a third dimension here, right? And what do I see? I see China's pretty big. I see India's big, okay? What else do I see here? Are there any other things people see when they look at this plot?
The country's location is by color, which is pretty cool.
The color is the country's location. And what do we see? The yellow ones are the New World countries, okay? And, you know, it looks like Africa is in the blue, okay? Asia's in the red, okay? Europe's in the, I guess the orange. What other stories do you see when you look at a plot like this? Is there anything else that strikes people? So first of all, this is plotting 4-dimensional data now. Does everybody see that that's 4 dimensions? Because the size, the dots, the size matters, the color matters, okay? What other things do you notice on this plot?
GDP is in log scale, and it's mostly a straight line, so that could
Right,
indicate
so
a
one
power
thing that
law.
they notice is that this is done in a log scale. And it does look like the countries are on a log thing that suggests kind of maybe almost like a power law type of thing. Okay, not quite, I guess, because that'd be a log plot. But you're right, it's interesting that in order for this to make sense, there is such a difference between very poor countries and very rich countries. There's a factor of 100 difference. If you made this linear, you would see all these dots would be crunched in a corner, okay? So yeah, so that was good. Are there any other stories this plot is telling you?
So we can see the quadrants like healthy and rich, healthy and poor, rich and sick, sick and poor. Like,
so there's quadrants. I think of it as being looking at what are the interesting outliers. Are there any countries here that look interesting to you?
South Africa stands out as a relatively rich country compared to its life expectancy.
South Africa is doing something wrong. That's one thing that's pretty clear, okay? Actually, I think this was probably during the AIDS crisis. They had a terrible AIDS problem. I think that's probably what that's capturing. Any other countries that look interesting from this?
Russia's kind of an outlier too.
Russia doesn't look like it's doing things right, okay? Any other countries? Which countries look like they're doing it right?
Japan, USA.
Japan, I guess you think looks like it's doing it right. Any other countries that impress you?
Vietnam is relatively healthy compared to
Vietnam is doing, considering even though it's a fairly poor country, it seems like it's relatively healthy, right? Any other countries that are interesting?
There are some small American countries. I think it's Cuba, Chile, and a few others.
Cuba looks interesting to me. It's a poor country, but their life expectancy is very close to the United States. Okay, so again, in an interesting data set, it will tell you all kinds of interesting stories. Okay, and I desperately encourage you to click on this link. Okay, and view the video. They actually show this they had another dimension of time by making this a video, okay? And it's really kind of exciting to watch, okay? Try to listen to me till the end of class, but maybe I will click the video at the end if we don't do it. What other graphics things are worth knowing about, okay? Now, some people like pie charts when you want to show a whole, okay? This shows pie charts. I guess that there are 3 sources of revenue from a country over. No, this actually looks like 3 sources of. It looks like they divided the country into 3 parts, and this is showing how much of a company's income came from each one of the parts of the country, the east, the west, or the central country. You could represent this by 3 pie charts. You could represent this by 3 bar charts. Which do people like better? Who here likes pie charts to show things? Who likes bar charts to show things?
Pie charts can be shown when, like, if you're showing the distribution, kind of like, say if the total is 100% and the green is some percent, red is some percent, and
this is showing you use a pie chart when you really want to get a sense of the fraction of the whole. That's what it's trying to show you. Okay. Who here likes the bar charts?
I like the bar chart because it shows
Why
you
do
how the
like the
total
bar
changes.
charts?
Shows you how the total changes over the 3 years.
It shows you that this is something that has been growing. Okay. How could we use our series of pie charts to show whether something's been growing or not?
You could change the size of the circle, but then you fall
The
into
area
the
of the pie. Okay, but actually, it's probably very hard to tell the difference between 2 pies of this of slightly different area. Okay, these may very well be of different sizes. It's hard for me to tell because the difference isn't that large. It shows up much better on the pie charts. So pie charts seem to be better for showing fractions. Okay. Many people like pie charts. Tufty, who I think is right on almost everything, he doesn't like pie charts. But I am, I'm less of a, religious about this. But you should see that one problem with pie charts is that they take up a fair amount of space. Okay, especially if you want to show a lot of them, and they're hard to compare what's really going on from one to another. Any questions? Here are 2 pie charts. Which ones do people like better? The one on the left or the one on the right?
Right.
Who likes the one on the right? Okay. Well, you might say, well, wait, look, it's 3 dimensions. It's cool. Look at how the pies are separate. Okay. How did they do that? Okay. But no, it's clear to me that the first one is better. Okay. By the anti-chart junk policy. Okay. What else makes this one on the left more interesting?
Percentages.
What?
The percentages are shown.
Percentages, I think, are actually a really good thing here. So not only do I see it, but I can actually read it, tell the difference of subtle things. Okay. It's not obvious from this pie who did better, Kasich or Rubio. Okay. But it is from the complete pie. Any questions?
If you're putting the numbers anyway, why not just use a table?
Well, you could use a table. Now, what would the table for this look like? Okay, a table here would be, this is a 2-dimensional table, name and percent. You could use a table. Do I think that you might get more visual oomph from the pie chart than the table? I think you probably get more oomph from it. Okay. You could, if you really are concerned about space, you could shrink the pie chart and it would probably still convey a lot of meaning. So I can see why someone would use the pie chart instead of the table. The table is not really that exciting because it doesn't permit you to do any comparisons. It's just numbers. Okay. So I guess I can see why I like this one. I think I like this one better than this, but certainly better than that. Okay. Again, you have to develop a taste or an aesthetic for this, and then you can decide what you like. Okay. But that's kind of what this unit's supposed to do, is to try to develop some kind of a taste. Okay. Histograms. When you're trying to view a distribution, okay, maybe you have a lot of observations. Typically, you have a histogram. That's the frequency. This is the value X. A histogram kind of represents something like a probability distribution. Okay. We could also represent the same data as a cumulative distribution. Everybody see here that we're going from 0 to 1, the fraction of it, okay? And this is a cumulative distribution. Both of these have the same information in them, right? You could, from one, construct the other. Which one do we think is a better visualization? Do people like the histogram or people like the CDF?
Personally, I like the histogram better.
Like the histogram better. Why do you like the histogram better?
Lets me know that data's bell-shaped, mostly normally distributed. I can't
see
see
that
that
it's
from the CDF.
bell-shaped. It looks very normal. Okay, see where the peak is naturally. Okay. Generally speaking, I will agree with you that I like the histograms better. But one thing that histograms do is they don't show you anything about what's happening at the tails. Usually if the tails are small there. Here, I get some better idea of what's there. But generally speaking, I agree with you. I like the histogram.
With the CDF and yeah, I mean, even in the histogram, you can see that the tail is just around like before 0.25, and even with the CDF, you can see the same thing. And CDF will always converge to a 1, we know. So, I mean, I don't understand how do you use CDF only for tails when you can see the tail, the same tail.
There's a question of how much stuff is at the tail. I claim is often obscured in a histogram. Okay, because kind of if you look at it, if you want to see what's going on at the tail, there's a lot more evidence of the kind of the tail here. Okay, at least I believe that. Okay, generally speaking, do I agree? I like if you're doing random sampling, like last class, I like my CDFs. Okay, if I'm doing my statistical test, like my KS test, I like my generally speaking, for visualization, I like histograms. What is the decision you have to make when you're building a histogram? Okay, it is the what you call it. You have to make a decision about how many bins to have. Which of these? Here we have the same data plotted with different number of buckets. Okay, which histogram is the one that shows the most meaning? Okay, if we look at the ones on top, which set of buckets do we think is right or shows more data, shows more the shape of the distribution?
Middle one?
You like the middle one? What do people like? Do people like the one on the left, the one on the right, or the one on the middle?
I vote right because it's a smooth enough curve that you're not distracted by any noise.
In this case, you have a large number of bins, and you can do that because you've got a large number. Again, there's very little up and down variance. Okay, this shows quite nicely. I think I like this one better. Okay, what about on the bottom? Here I have another set of points. It looks like this one I had something like 10,000 points, or no, I think I had 100,000 points. Here I'm taking, I think, 100 points. Okay, which one of these number of buckets looks most revealing to you? Do people like the left, the right, or the center?
Center.
Center, do people like that? Okay. What would be a criteria to set the number of buckets? It should be clear that histograms can look wildly different depending upon how many buckets you use, right? What if you use any real number distribution, but with extremely, as many buckets as there are points? Very, very fine buckets. What would the histogram look like? Look something like this. Okay. So typically you want to set the bucket size. I mean, there's some criteria people use. I usually do it so the average bucket size is 20, 30, something like that. You want enough points on an average bucket to see something, okay? But it should be clear that the appearance of a histogram, okay, what's going on will change wildly depending upon the number of buckets you use. Okay. If you have a large number of points, you can support a large number of buckets. Okay. If you have too few buckets, you get a very, very crude approximation to the distribution. You should be aware that this is a degree of freedom that's important to play with. Any questions?
Wouldn't it also depend on like what I'm trying to see, as in if I just want to get an idea of what's the count between 0.28 and 0.30? I mean, like what kind of a x-axis I'm looking for?
Okay, so when I give in grades, when I give my exams in classes, I always show a histogram where the buckets are 10-point distribution.
Yeah. So yeah.
Okay, and that's then where the bucket size conveys information. People are used to thinking about grades in terms of 100, and that grade changes typically happen every 10 points or so. So you're right. In that case, I do set my bucket size to convey a particular meaning. Okay, so it probably would be good to have bucket sizes that are interpretable numbers. Okay, and so often that has value. Realize so that the decisions you have to make: do you use an interpretable division, which I think is good, and do you make sure that you have enough points per bucket that you don't end up getting weird perceptible effects. Here, when you look at this, you don't notice the bell-shaped distribution. Okay? Here you're probably seeing things that are probably not that important. Okay? That's why I kind of like this and I kind of like that. Any other questions? When you're displaying a histogram, there's often the question of do you normalize it and show a fraction, or do you actually show the counts? So a density histogram, you're showing the fractions. Otherwise, you're showing the counts. The bars look the same here because all we're doing is scaling the label, changing the label on the axes. Which do people like better, a frequency histogram or a density histogram? Which conveys more information?
Frequency, because the density is almost implied by the visualization.
So one possibility is you say this probably shows more information in that it shows I know how many samples there are. That's one thing that this has done. But on the other hand, the interpretability, for a lot of things, I will claim a probability distribution, knowing what the total n is I think more interpretable. But recognize that's kind of what you're trading off. Either the story you want to tell is that there's a large proportion that is here, or you want to say that it's a large number and these are slightly different things. Any questions? Okay, any questions about any of this? Okay, what I'm going to do is now leave. Let me just see if I can turn on the video on this. And the answer seems to be no. What I want you to do is to go look at this. I'm going to walk away, actually. But I want you guys to go take a look at the video because it's actually very, very cool and inspiring. Okay? Any questions? If not, when you finish the video, is there a way for you? Yeah, okay, how would I show you the video? Let me undo this. Let me see if I'm capable of doing something like this. If I went to 519, hold on a second. Hold on 1 second. Okay, I'm gonna, hold on, let me share if I can do this.
Visualization is right at the heart of my own work too. I teach global health. And I know having the data is not enough. I have to show it in ways people both
Can
enjoy
people see
and
anything?
understand.
Yes.
Yes.
Now, I'm going to try something I've never done before. Animating the data in real space with a bit of technical assistance from the crew. So here we go. First, an axis for health, life expectancy, from 25 years to 75 years. And down here, an axis for wealth, income per person, $400, $4,000, and $40,000. So down here is poor and sick, and up here is rich and healthy. Now, I'm going to show you the world 200 years ago, in 1810. Here come all the countries. Europe brown, Asia red, Middle East green, Africa south of Sahara blue, and the Americas yellow. And the size of the country bubble showed the size of the population. And in 1810, it was pretty crowded down there, wasn't it? All countries were sick and poor. Life expectancy were below 40 in all countries. And only UK and the Netherlands were slightly better off, but not much. And now, why start the world? The Industrial Revolution makes countries in Europe and elsewhere move away from the rest. But the colonized countries in Asia and Africa, they are stuck down there. And eventually, the Western countries get healthier and healthier. And now we slow down to show the impact of the First World War and the Spanish flu epidemic. What a catastrophe. And now I speed up through the 1920s and the 1930s. And in spite of the Great Depression, Western countries forge on towards greater wealth and health. Japan and some others try to follow, but most countries stay down here. Now, after the tragedies of the Second World War, we stop a bit to look at the world in 1948. 1948 was a great year. The war was over, Sweden topped the medal table at the Winter Olympics, and I was born. But the differences between the countries of the world was wider than ever. United States was in the front, Japan was catching up. Brazil was way behind, Iran was getting a little richer from oil, but still had short lives. And the Asian giants, China, India, Pakistan, Bangladesh, and Indonesia, they were still poor and sick down here. But look what is about to happen. Here we go again. In my lifetime, former colonies gained independence, and then finally they started to get healthier and healthier and healthier. And in the 1970s, then countries in Asia and Latin America started to catch up with the Western countries. They became the emerging economies. Some in Africa follows. Some Africans were stuck in civil war and others hit by HIV. And now we can see the world today in the most up-to-date statistics. Most people today live in the middle, but there are huge differences at the same time between the best of countries and the worst of countries. And there are also huge inequalities within countries. These bubbles show country averages, but I can split them. Take China, I can split it into provinces. There goes Shanghai. It has the same wealth and health as Italy today. And there is the poor inland province Guizhou. It is like Pakistan. And if I split it further, the rural parts are like Ghana in Africa. And yet, despite the enormous disparities today, we have seen 200 years of remarkable progress. That huge historical gap between the West and the rest is now closing. We have become an entirely new converging world. And I see a clear trend into the future. With aid, trade, green technology, and peace, it's fully possible that everyone can make it to the healthy, wealthy corner. Well, what you just seen in the last few minutes is a story of 200 countries shown over 200 years and beyond. It involved plotting of 120,000 numbers. Pretty neat, huh?
Okay. Anyway, thanks for your attention, and hopefully that's inspiring, at least inspiring to do your homework. And think about these, and we'll talk a little bit more about visualization next class.